So now we're ready to attempt apportioning our seats. So we're going to do this calculation that we've done here, where we take the population of the district, divide it by the total population, and multiply it times the number of seats. So District 3 is the one we're told to do in number 5. It had 41,000 people, and the total population was 240. So we're getting the percent of the total population that this district represents, and then we're going to multiply it times the 20 seats. So I'm going to rely on decimals for this calculation. So here goes 41,000 divided by 240,000. Notice the thousands cancel, and then we're going to multiply that times 20, and we get 3.417 approximately. Okay, so what is this thing? Well, this is seats. So this is the number of seats that District 3 should receive. Unfortunately, we can't give 0.417 of a seat, right? So that's a problem. It turns out what we just wrote, that formula, is actually called the standard quota. And so if it were possible to hand out these fractional portions, this is the standard quota that each district would get. Turns out it's a nice quick little calculation that's less complicated than we had before. You just take the population of the district and divide it by the standard divisor. So we are going to find the quota for the rest of these ones. So District 1 had 32,000 people. If we divide that by the 12,000, which was our standard quota, that will get us, which was our standard divisor, that'll get us the standard quota for District 1. District 2 is 80 divided by 12. District 3 we just did. There's 3.417. District 4 we need 67 divided by 12. And District 5 we're looking at 20 divided by 12. So I'm going to get all these in decimals in one fell swoop. 32 divided by 12, 2.67 approximately. 80 divided by 12 gives us approximately 6.67. Notice I'm just doing 2 decimals for each of these. It doesn't particularly matter, but I think 2 decimals is a pretty good good rounding to stick with. All right, and finally 20 divided by 12, that is approximately 1.67. So we found each of the standard quotas for all of the 3 districts. So we know almost how many each district should get. Note again, all of these have fractional parts because of those decimals. So how do we turn this into a good apportionment? Well, we have to come up with some sort of method. So this says round each of the standard quotas you calculated in question 6 to the nearest whole number, then add the result and explain why that doesn't work. Okay, so I'm going to round each one of these to the nearest whole number. This would become 3. This would be 7. District 3 would be a 3. District 4 would be a 6. And District 5 would be a 2. So let's add this up. What we're saying is these are the number of seats that each of these 5 districts should get. So what's the sum of all this? Well, let's see. 3 plus 3 is 6, plus 6 is 12, plus 9 is 21. That's 21 seats, which is 1 more seat than available. So this doesn't work in this case because we have too many seats to give away, sorry, not enough seats to apportion this. So who gets shorted a seat is what we have to decide. So question 7 shows that simply rounding each standard quota to the nearest whole number isn't a reliable method of apportionment. This was realized back in 1790 when both Alexander Hamilton, this guy, and Thomas Jefferson, this guy, suggested methods for apportioning congressional seats after our nation's first official census, meaning here's where we for the first time, figured out how many people are out there. So the methods of apportionment are based on first calculating the standard quota. All right, that's what we did. Then we decide whether to round up or down. So for any district, the lower quota is the result of rounding the standard quota down to the next lower whole number. I'm going to demonstrate that in a second. And the upper quota is rounding up. So we're going to stick with the same problem we just did. I'm going to copy down all of the standard quotas. District 1 had 2.67, 6.67, 3.42, rounding to 2 decimals, 5.58, 1.67. Now here's where it gets a little tricky. When we do lower quotas, we're rounding down, meaning we're ignoring the decimal and we're just writing out the number. So 2, 6, 3, 5, 1. I know you want to write it rounding up when the number is greater than 5, but this is what we do with the lower quota. And then the upper quota, we now round up, meaning just add 1 to the lower quotas. 3, 7, 4, 6, 2. So we're now ready to do a particular apportionment strategy.